Picture a hot, sunny day. You're out for a run and pouring sweat. You get into your apartment, and even though you might not have air conditioning, you start to feel cool and might even get the chills. Why does sweating keep us cool, even in warm temperatures? The answer is evaporative cooling, the process of liquid water evaporating from a surface, which decreases the surface's temperature. When sweat evaporates from our skin, it usually leaves us feeling cool. The droplets of sweat on the person's arm in the image on screen here help to regulate his temperature. To understand evaporative cooling, we also need to understand heat and evaporation. Water can hold a lot of heat without changing temperature. The heat stored in water is called latent heat. Water absorbs the heat from other surfaces, making them cooler. When water absorbs enough heat, it evaporates or changes from a liquid to a gas. The gas leaves the surface, taking the extra heat with it. The result is a decreased amount of heat and thus decreased temperature in the surface. This is how evaporative cooling works. Think of how boiling noodles on the stove works. The stove transfers heat to the water in the pot. The water absorbs the heat and then leaves the pot as steam, taking the heat with it. Evaporative cooling is used in both biological and mechanical processes. Our bodies are designed to sweat to release heat and keep our body at its natural temperature when it gets too hot. Our skin releases sweat, which contains water. The water absorbs the heat from our skin and it eventually evaporates, taking the extra heat in our skin with it. This decreases our body temperature and keeps us from overheating in the summer. Air conditioners use evaporative cooling to decrease the temperature inside a building. Evaporative coolers work by pumping warm air into the air conditioner and filtering it through a pad soaked with water, which can absorb heat from the air and evaporate. As the water absorbs heat from the air temperature decreases and is returned to the room. Evaporative cooling is also used to cool nuclear power plants. The heat from the nuclear core flows into water cooling systems. The water absorbs the heat and is released as steam from the power plant. Without proper cooling systems, nuclear power plants overheat and a nuclear meltdown occurs. Radioactive material can escape into the environment. Evaporative cooling only works if the water can evaporate into the air. Air has a maximum amount of water it can hold. This is called humidity. When the air is very humid, there is not much more room for water to evaporate. Thus, the warm water on the surface can no longer evaporate into the air, and the heat stays with the surface and the water. This is why you probably feel a lot warmer on a hot, humid day than during dry conditions with the same temperature. The high humidity prevents the water from evaporating, and thus, no evaporative cooling can take place. In summary, evaporative cooling is the process of removing heat from a surface due to the evaporation of water. Water can absorb a lot of heat without changing phases, allowing it to remove heat from the surface it is on. But water turns from liquid to gas, it's called evaporation. The heat water stores is called latent heat. Since the heat is going from the surface into the water, the temperature of the surface decreases. Eventually, water absorbs so much heat that it evaporates, taking the heat with it and leaving the surface with a lower temperature. If the air has too much water in it, humidity occurs, since it's the maximum amount of water it can hold. Evaporative cooling is important for keeping our bodies at a normal temperature, which occurs through sweating. It is also important for regulating the temperature of our environment through the use of evaporative coolers, better known as air conditioners, which work by pumping warm air into the air conditioner and filtering it through a pad soaked with water, which can absorb heat from the air and evaporate. This is similar to how nuclear plants keep their reactor cores cool.